Good morning. I hope you guys had a great day yesterday. Today we're going to end up seeing limits in terms of approaching infinity and negative infinity, okay? And so in this case, you have rational functions. So there are functions that are written as a fraction. You have a numerator and a denominator, okay? So just to remind you what a rational function, it's a numerator and a denominator. It looks like a fraction. So now, these are the way we are able to express the limits going towards infinity, okay? So we have three cases. The first case is, remember your degree in terms of your exponent. So you are taking your highest degree, and what we mean by that is highest degree, and we're talking about the exponent, okay? So you're going to look at your highest degree, which is your exponent, from both the numerator and the denominator, okay? If the degree of my exponent is bigger on the bottom, then my limit is going to approach 0, okay? Bigger on bottom, the limit is going to be 0. Okay? Again, if that degree is bigger on the bottom, my limit is going to be 0. If the degree equals, so in this case, if they're equal, you're just going to take the ratio of the coefficients, okay? And I'll show you an example of each one of these. And then the third case we have is if the degree is bigger on top, then your limit is undefined. It does not exist. The limit does not exist. It is undefined. Okay? So now we're going to see these examples. So first thing, we have a case here where we have a function, sine 2 of x over x. I don't know how this function looks like. So what do we use to be able to graph this function? We go to Desmos. And open another Desmos. Okay. And we're going to type in our function right here. Let me just make sure it's sine 2x over x, okay? Here's my function. Okay, and this is how it looks like. So you can see a better picture. And then it said as it is approaching infinity. So as it is approaching infinity, if I keep going, you notice how if I were to zoom out, where is it approaching? It's making like a line towards 0. So come back over here. As x is approaching infinity, what is my function approaching? My function is approaching 0. So right here it would be 0. As it is approaching negative infinity, it was also approaching 0. Okay, so this is positive infinity to the right, negative infinity to the left. They're both approaching 0. Okay, so that's what you're going to use when you don't have a graph. Just go to Desmos. Now, here in the second, these next three examples, you're not going to use it. You're going to look at, it's a rational function. I'm able to compare my highest exponent. So, in your numerator, what is your highest exponent? It's 2. In my denominator, remember when I just have x by itself, the exponent is 1. So, exponent 2 on top, 1 on the bottom. So when it's bigger on top, what did we say? Let's go back. Bigger on top. Here you go. What case do we have? So bigger on top, we said it is undefined. The limit does not exist. So for this one, the DNE, it does not exist. Okay. Next example. We have highest degree in the numerator is 2. Highest degree in the denominator is 3. Bigger on bottom, what did we say our limit is? 0. And then in our last case, we have, here is 3. Okay. I have 3 for this one. And I have 3. They are the same. So now we're just going to look at the coefficients. And what we mean by the coefficients, x cubed, the coefficient of x cubed is 1, right? So I have 1 over, and the coefficient of x cubed in the denominator is 5. So my limit is 1/5. Just the way we did it here, that's how I want you to try the problems in the homework. Take care. If you have any questions, send me an email.